Hello children, welcome once again to our fourth session wherein we shall be discussing about the coordinate geometry. Okay, in this chapter we shall try to find the distance between 2 points. In your earlier class, that is your lower classes, you have already learned how to locate a point. Now here, for your 10th class, we shall be starting with finding the distance between the points. Now here, we have different cases to find the distance between the points. One is for points lying on x-axis. The other is points lying on y-axis. And again, points lying on a line parallel to the axis. Then points lying on axis. One point will be lying on x-axis and the other point will be lying on the y-axis. And the last one here is distance between the points which are lying on lying in xy plane. Okay. Now we shall first start our discussion with points lying on x-axis. That is, we shall now try to find the distance between the points which are lying on the x-axis. You know very well which points lie on x-axis. Now observe carefully here. This is x, O, x dash, that is x-axis. Similarly y, O, y dash, y-axis. This is positive part of x-axis, this is positive part of y-axis. Here this is negative part of y-axis and this is negative part of x-axis. And this is O, 0, 0, the origin. Now take for example point 2, 0. Here x coordinate is 2, y coordinate is 0. So the points whose y coordinates are 0, they lie on the x-axis. Now again here I have chosen one more point B whose coordinates are 6, 0. Here the y coordinate is 0. Therefore this point B also lie on the x-axis. Okay, now we shall try to find the distance between these 2 points, that is A and B. So for points, distance between the points A and B, how to find the distance? From origin to here it is 6 and from here to here it is 2. 6 minus 2. 6 minus 2 is equal to 4 units. So this is the distance between the points A and B. Okay. Now we take another case. For example, let us imagine this is the point now here A whose coordinates are minus 2, 0. And here this is the point B whose coordinates are minus 6, 0. Again, from here to here it is x2 and from here to here it is x1. So here to here it is minus 6 and here to here it is minus 2. So minus 6 minus of minus 2. Okay, so this is minus 6 minus of minus 2 is plus 2. Minus into minus plus. So here minus 6 plus 2, it is minus 4 units. Okay, but in general the distance cannot be negative. So we have to take only positive part of the value. So for that, in general, we write the formula for the distance between the 2 points lying on x-axis as modulus x2 minus x1. Modulus x2 minus x1. So this means that even if we get the negative value, then it has to be treated as a positive value. That is, we have to take the absolute value because the distance cannot be negative. For instance, see this one, minus 6, okay, minus of minus 2. So now here it is minus 6, minus of minus, as said earlier, it is plus 2. So it is modulus minus 4. Modulus minus 4 is always plus 4. That is 4 units. So this is how we find the distance between the 2 points which are lying on the x-axis. So what is the formula? modulus of x2 minus x1. Now again, let us imagine that the points are lying on y-axis. On y-axis, the x-coordinate will be 0. For example, you take this point. So here, x-coordinate is 0. So the point A, 0, 2. Again, if we choose this point as B, then here the coordinates of this point are 0, 6. Okay. Now for this, from here to here it is 6 and here to here it is 2. So 6 minus 4 once again is 6 minus 2, it is once again 4 units. Likewise, if we take negative value, then we use this modulus to get the positive value of it. So in general, to find the distance between any two points lying on the y-axis, we write the formula as modulus y2 minus y1. Modulus y2 minus y1. Okay. So these are the two formulae which we use to find the distance between the points lying on x-axis and for the points lying on the y-axis. So this is one case. Now we shall discuss one more case, that is for the points which are lying on a line parallel to the axis. So now imagine this is a line which I have drawn, and let us imagine that the line is parallel to x-axis. So this is the point A now here, and this is the point B here. Okay. Now here to here, if we drop a perpendicular, say it is P, and from here to here if we drop a perpendicular, say it is Q. Now the coordinates of the point A can be written as x1, y1. x1, here to here it is x1, and here to here it is say y1. Now for the point B, this is x2, y1. x2, y1, because there is no difference in the height here. Okay, so y1 remains same. Now distance between the 2 points A and B, how to write it? So here to here it is x2 and here to here it is x1. So again the distance between the 2 points is modulus x2 minus x1. So I will show you on the board here. Right. And now observe this case where these two are the points on the line AB. Now how to find the distance between the points A and B. Now this is a perpendicular, and the distance between O and P is x1 and the distance between O and Q is x2. Now to get the distance between PQ, how to write PQ is equal to OQ minus OP. PQ. This distance is equal to OQ minus OP. So what is OQ? It is x2, and what is OP? It is x1. Now if we observe carefully, as these are two perpendiculars, this PQ is equal to AB. So AB, the distance between the points A and B, it is equal to PQ. So which is again equal to x2 minus x1. Therefore AB is equal to modulus x2 minus x1. So this is the formula which we use to find the distance between any two points that are lying on a line parallel to the x-axis. And again, if it is a case of y-axis, we write this as AB is equal to modulus y2 minus y1. That is when the line is parallel to the y-axis. I hope you have understood up to this. Okay, we'll proceed to the next case then. Okay children, now we shall try to find the distance between 2 points which are lying on the coordinate axis. That is, one point lying on the x-axis and the other point lying on the y-axis. I have chosen this 40, B40 as a point lying on x-axis and the point A 0, 3 lying on the y-axis. Now I will join A and B here to get the line AB. Now we shall try to find the distance between these 2 points A and B. Clearly, if you happen to observe, this is a right angle triangle OAB. O is the origin here, OAB. And in a right angle triangle, we can apply Pythagoras theorem to get one of the sides if we know the other 2 sides. So this is the side opposite to the right angle and we call it as hypotenuse. So according to Pythagoras theorem, AB square, square of the hypotenuse, AB square is equal to OA square plus OB square. OA square plus OB square. Okay. Now OA square, OA is nothing but 3 units. Okay. From here to here, the distance of the point A on the y-axis is 3 units. So this is 3 square and clearly this OB is 4. So it is 4 square. 3 square is 9 and 4 square is 16. The sum of these two is 25. Now to get AB, where AB is the distance between the 2 points A and B. How to get? So square root of 25. Square root of 25 is nothing but 5 units. So this is how we have found the distance between the 2 points A and B which are lying on the coordinate axis. Now in general, to write the formula here, so we can assume this 4 units as say x and here this as y. So distance between the 2 points AB can be written as square root of x square plus y square or y square plus x square plus y square. So what is this formula? This is the formula to find the distance between the 2 points A and B which are lying on the coordinate axis, that is x axis and the y axis. Okay, now we shall switch on to the very important part to find the distance between 2 points on a line which is lying in the plane xy. Okay. Okay children, as I said earlier, now we are trying to find the distance between 2 points, say A and B, okay, which is lying in between the coordinate axis x and y. So we call in general xy plane. Okay. Now we are finding the distance between 2 points lying in the plane xy. Points lying in the plane xy. That is distance between the points lying in plane xy. Okay. Now you see here, I have selected 2 points, A whose coordinates are x1, y1 and B whose coordinates are x2, y2. I have joined these 2 points to get a line AB. Okay. Now what I have done is I have dropped a perpendicular onto x-axis, writing this as B, and again from B I have dropped one more perpendicular onto y-axis, writing this as Q, and again from A I have dropped a perpendicular such that the point on QB is R. Okay. Now you see here OQ, from here to here it is x2. Okay. Again similarly OP, it is x1, from here to here it is x1. So if I want to get the distance PQ, then how am I to get it? PQ is equal to OQ minus OP. OQ minus OP will give me the distance PQ. So PQ I have calculated here as x2 minus x1. Now this PQ, it is equal to AR. So AR is equal to PQ, that is equal to x2 minus x1. Similarly, on the other side, you see from here Q to B, it is y2. Okay. Again q to r it is y1. So RB, this distance, if I want, how to get it? QB minus QR. QB is y2 and QR is y1. So RB is equal to y2 minus y1. So if you observe carefully again here, ARB is a right angled triangle in which AB is the hypotenuse. AB is the hypotenuse. Now we shall try to get the distance between the 2 points A and B using the Pythagoras theorem. So AB is a hypotenuse. So we can write this as AB square. AB square on the hypotenuse is equal to AR square plus RB square, the other two sides. Okay, sum of the squares of the other two sides. Okay, now here AR square. What is AR? AR is x2 minus x1. For square it is square. Then again RB square. How to write it? y2 minus y1 whole square. So this is AB square. Now to get the distance AB, then AB is equal to square of x2 minus x1 whole square plus y2 minus y1 whole square. So this formula which we have obtained to find the distance between the 2 points A and B lying in the plane xy is called the distance formula. And once again I am repeating, this formula is called the distance formula, and which is very important to solve the problems pertaining to this chapter. Now using this formula we shall try to solve one or two problems so that it will be helpful for you to know how to proceed further in order to find the distance between the points. Okay. Okay children, we have found the distance formula just now, isn't it? How we have got it? What is the formula? Distance formula? AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Now using that formula we shall try to find the distance between the points. See, I have chosen two problems for you here. So the first one is find the distance between the points minus 5, 7 and minus 1, 3. Okay. Now first we shall try to solve this problem. Now how to solve it? Let the 2 points be. Let the 2 points be. What are the 2 points? We are naming it as A, minus 5, 7, and the next point, that is B, minus 1, 3. Okay. Now the distance between A and B we have to find. So next step we will write the distance formula. What we have learned earlier. Distance formula. What is distance formula? It is root of x2 minus x1 whole square plus y2 minus y1 whole square. So here in this we can write this as x1, this as y1. Here this can be assumed as x2 and this can be assumed as y2 for the sake of simplicity. Okay, so the distance between the points A and B is equal to root of, you see here, now x2. What is x2? Minus 1. x2 is minus 1. Again, here it is minus, so minus x1. x1 is minus 5 again, minus 5. Okay, so x2 minus x1 whole square, okay, plus y2 minus y1 whole square. y2, what is y2? It is 3 minus y1. y1 is 7. 3 minus 7 whole square. Okay. So just to avoid the confusion here, I have used the brackets. Okay. Now here square root of minus 1 as it is here minus into minus it is plus whole square plus 3 minus 7 it is minus 4 whole square. Okay, now here 5 minus 1. 5 minus 1 is 4. So 4 square. Again here it is minus 4 whole square is nothing but plus 4 square, or you can simply write here 16. Okay, 4 square is 16 plus 16. It is root of 32. Again, still we can simplify this. So how to simplify? 32 can be written as say 4 into 8. 4 8 32. So I am writing this as root of 4 into 8. So root 4 is 2. I am writing it outside, and here it is 8. Okay. Still again this 8 can also be written as a factor of 4 into 2. Okay. 4 into 4 into 2. 4 4 16. 16 2 32. So here simply I can write this as this is 4 into 4. 4 square. So for 4 square, root of 4 square is 4. Root of 4 square is 4. And I am here left with 2. So 4 root 2 units. 4 root 2 units. Even you can write this as 16. 4 into 4 is 16 into 2. Root 16 is 4 and root 2 I am writing it as it is. So 4 root 2 units. So this is how we calculate the distance between the 2 points A and B, whose coordinates are see minus 5 7 and minus 1 3. Okay. So now we shall try to solve the next problem. See what is the next problem here. Show that the points 4 2, A 4 2, B 7 5 and C 9 7 are 3 points lying on the same line. Lying on the same line in the sense the points are called collinear points. The points are called collinear points. All the 3 points lying on the same line. Now if we express the sum of 2 parts as the other one, then that is enough here. Again we have to find the distance between the points here. Now we will find the distance between the points first A and B, then B and C, then A and C. Okay, then we will come to know how to show that all the 3 points are lying on the same line. Okay, now we shall try to proceed to solve. Okay, now what is that we are trying to do? We are trying to show that these points A, B and C, they are lying on the same line. Okay, now given points. What are the given points? It is A 4 2, okay, B 7 5 and C 9 7. These are the given points for us. Now distance formula, once again try to recall. Distance formula is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Using this, let us find the distance between A and B. A, B. This is equal to root of. Here now this time it is x1, y1 and this is x2, y2. So x2 minus x1, 7 minus 4, 7 minus 4 whole square plus y2 minus y1, 5 minus 2, 5 minus 2 whole square. Okay, 7 minus 4, it is 3. So 3 square plus, then again 5 minus 2, it is once again 3. Okay, 3 square. So this is root of 3 square plus 3 square. This is root of 3 square is 9 plus again this is 9. 9 plus 9 is 18. Okay, root 19. We can write even this as 9 into 2. Root of 9 into 2. Root 9 is 3. This root 2 I will write as it is. So this is 3 root 2 units. What is this one? AB. Distance between the points AB. How much it is? 3 root 2. Okay. In a similar way, we shall find the distance between the points B and C. Here in this case, this is x1, this is y1, this is x2, this is y2. Okay. Now again, x2 minus x1 whole square. So 9 minus 7 whole square. 9 minus 7 whole square. Okay. Plus y2 minus y1 whole square. It is 7 minus 5. 7 minus 5 whole square. See, BC is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. 9 minus 7 is 2 square plus 7 minus 5 is 2 square with root. Okay, root of 2 square is 4 plus again 2 square is 4. 4 plus 4 is 8, root 8. Root 8 can be written as root of 4 into 2. Okay, root 4 is 2. Root 2 I am writing it as it is. So 2 root 2 units. 2 root 2. What is this one? This is distance between the points B and C. In a similar way, now I shall find the distance between the points A and C here. So this time, for A I am writing this as x1, y1. Okay. For C I am writing it as x2, y2. Same formula I am using here. Okay. Root of, so root of x2 minus x1 whole square. Here this time x2 is 9, x1 is 4. 9 minus 4, 9 minus 4 whole square plus y2 minus y1, 7 minus 2. 7 minus 2 whole square. 7 minus 2 whole square. See how much I am getting? 9 minus 4 is 5, which is square. Then again 7 minus 2 is 5 square. Then again 5 square is 25. Again here also 25. 25 plus 25 is 50. Root 50. This one can also be simplified. So how to simplify this one? 50. 10 into 5 I can write like that. 10 into 5. Or is there any other idea to write it so that if I add these two, 2 root 2 plus 2 root 2, it should be 5 root 2 like that. So I'll write like this simply, 25 into 2, which is 50. Square root of 25 is 5. Root 2 I am writing it as it is. So 5 root 2 units. See what is this? It is the distance between the points A and C. Now clearly, if we observe, okay, if we observe carefully, now AC can be written as sum of AB and BC. You see here, AC, what is AC? 5 root 2. Isn't it? AC is 5 root 2. What is AB? AB is 3 root 2. What is BC? 2 root 2. So AC can be written as, see, AB plus BC. If you want, you can recalculate here. So what is AB? AB is 3 root 2 units. And what is BC? 2 root 2 units. Okay. So I am taking root 2 as common here. So I am left with 3 plus 2. Okay. 3 plus 2 is 5. 5 root 2 units. So it's very clear to you now. So AC, what is AC? 5 root 2. 5 root 2 is equal to AB plus BC. That is, sum of these two parts, if we add these two parts, we are getting this line AC. Okay? So it's very clear that all the 3 points A, B and then C, they are lying on the same line. See, I am showing you here. See, this is A, this is C. Here up to here it is B. From here it is BC. AB plus BC. So this AC is equal to AB plus BC. Isn't it? So it's very clear that the points A, B and C which are given to us, they are lying on the same line. So if for such points we call them as collinear points. A, B and C are called collinear points. I hope you have enjoyed this session, and we shall meet again in the next class. Till then, bye bye. Have a good day.